Okay, so let's take a little bit of a deeper look into what y-intercept is really, what it means in terms of what we've been leading up towards, which is seeing what y-intercept is in terms of real world, real life problems, right? So, first thing you got to realize is the y-intercept in real life problems is also known as the initial value. It's the starting place of your graph, right? And the graphs we're going to look like in real life are all in the positive quadrant number one, right? And we're just looking at ones like this, right? And you can see the y-intercept right there. And notice it's actually the starting point because now we have a ray going in one direction and it actually starts at the y-intercept, right? And that's also called the initial value. So there's the y-intercept right there. And again, the initial value, otherwise known as the y-intercept, where the graph starts, right? Initial, like your initials. That's where your name starts, right? What is it? At 0, 1000, right? Nothing new there. You guys have been finding the y-intercept for a while, all right? And in this one right here, same idea, right? Now this one, y-intercept is right down there at the origin, right? So the initial value there is 0, 0, right? So let's just talk about what this initial value means in terms of a couple of problems. All right, so look at this one right here. Here's the second one we just looked at, going through the origin at 0, 0. Well, what does that 0, 0 mean? So I want you to zoom in to the labels on each axis. The x-axis is the time in hours, and the y-axis is the distance in miles. Now, we don't even have a title here. We don't know what else is going on, but we're just using this to understand what does that point mean in terms of this problem. All right, well, let's take a look, right? So we have 0, 0. That's when x is 0, then y is 0, right? X is 0 and y is 0 there, right? We start with x is 0, y is 0. It's right there. That's 0, 0. Well, look at what that means. All right, that means what is x? X is time, right? In hours. So what does that mean in terms of this? That means when the time is 0 hours. So there's no hours there, right? The hours are 0 for the time. And then we look for, well, the y. What's the y? Well, the y is what? The distance. And the distance is in miles. Well, what's going on? Well, at the 0 time, we also have a distance of 0 miles. So you can see that what this y-intercept means in terms of this problem is it's 0, 0, but that's 0 when the time is 0 and the distance is 0. Let's look at this one. All right. Now, this one has a 0, 1000 of initial value right there. 0 for x and y is 1000. Right? Well, what does that mean in terms of the problem again? Again, let's look at the axis. Let's look at the x-axis. What is that? Again, it's time, right? And we'll notice here, still x is 0. Remember, the y-intercept is always when x is 0. So in this case, when the time is at 0, at the start, right? That means at the start of this, at 0 hours. That means, boom, that's when we started. That's the 0 hour. What's going on? Let's look at the y, right? That's the water in the pond in liters. And it looks like it's increasing, right? So it looks like we're filling water here into a pond, right? So then the water is at 1000, right? So when we started filling, we already had 1000 in the pond. So when the time was 0, the water was 1000 liters. That's it. All that means in terms of this problem, that at the initial, at the start, at the beginning, when the time was 0, that's our x, water was at 1000 liters. So that's all we're going to practice, is making sure we can see this connection between what does the y-intercept mean in terms of the actual problem. All right, so let's go take a look at this, and we're going to practice this.